Thanks for watching my video. Prove another gamma function. Okay, so gamma s, gamma 1 minus s is pi over sin pi s. This is Euler reflection formula. Okay, and again this all these two is equal to sum from integral from 0 to infinity x to the s minus 1 upon 1 plus x dx. Okay, we are going to prove that this integral is equal to this gamma function gamma s, gamma 1 minus s is equal to this integral. Okay, let's try to prove that. Now using the integral representation of gamma function, we have gamma s is integral from 0 to infinity e to the negative x into x to the s minus 1 dx. Okay, now gamma s, gamma 1 minus s is gamma s is substitute here integral from 0 to infinity e to the negative x to the s minus 1 dx, and gamma 1 minus s, if you substitute here 1 minus s. Now let's use different variables. Okay, so that if we use the same variable, it won't work. Okay, it's something like this integral whole square, something like that. Okay, now let's choose different variable. Even though we choose different variable, the integral does not change, right, by property. Therefore I'm going to choose another variables y, and gamma 1 minus s is integral from 0 to infinity e to the negative y to the, here s is nothing but 1 minus s, so 1 minus s minus 1 dy. So 1 can get cancelled. Okay, so gamma s, gamma 1 minus s is integral from x equal to 0 to infinity and y equal to 0 to infinity e to the negative x e to the negative y x to the s minus 1 y to the negative x dx dy. Now gamma s, gamma 1 minus s is equal to integral from 0 to infinity and integral from 0 to infinity, then this is for x. Okay, and this is for y, and x e to the negative x e to the negative y, and then we can change that one. Okay, x to the s minus 1 y to the negative x is x to the s minus 1 into here y. If I put negative x plus 1, okay, then I am going to inverse again. Okay, right? So this is x to the s minus 1 into, this is same as y to the s minus 1, right? Y to the s minus 1 into y inverse, so which is x by y to the s minus 1 into y inverse. That's why x by y s minus 1 y inverse dx dy. Now gamma s, gamma 1 minus s. Now let's change the integral. So integral from, this is, let's keep y. Okay, integral from y equal to 0 to infinity e to the negative y, and this is for x integral from x equal to 0 to infinity e to the negative x and x by y to the s minus 1 dx, and y inverse here dy. Okay, now put x by y is equal to u. Here y is constant. Okay, here we treated y as constant because y does not depend on x. Okay, therefore x by y is equal to u, then is x equal to yu, this is dx is y du. Okay, now gamma s, gamma 1 minus s is integral from y, this is y equal to 0 to infinity e to the negative y. Now if you substitute 0 in place of x 0, then it will 0 infinity, that it does not change, so e to the negative x is yu or uy, and x by y is u, u s minus 1, and dx is y du, and y inverse dy. Then you get gamma s, gamma 1 minus s is integral from 0 to infinity, and this is x, this is u again now. Okay, these two integral interchange it, so integral from u equal to 0 to infinity u to the s minus 1, and this one integral from, this is for y again. Okay, y equal to 0 to infinity e to the negative y into e to the negative, this is not for, okay, uy into y inverse dy and du. These two can get cancelled. Therefore gamma s gamma 1 minus s is integral from u equal to 0 to infinity us minus 1 and integral of 0 to infinity. Now using exponential law, it will be e to the negative u plus 1 y dy, right, and du. Now this is easy to integrate, right? Gamma s gamma 1 minus s is integral from 0 to infinity. This is for u, okay, us minus 1. If you integrate this, e to the negative 1 plus y, 1 plus u into y upon negative 1 plus u from integral from 0 to infinity and du, okay, don't forget du. Now continuing here. Now gamma s gamma 1 minus s is integral from, this is for u value, okay, u equal to 0 to infinity u to the s minus 1. Now this one taking out here 1 plus u, then integral from negative is there, negative e to the negative, if you put infinity then you get e to the negative infinity minus, and this minus will become plus e to the, if you put y equal to 0 then it will be e to the 0, right, and du. We know that e to the negative infinity is 0 and e to the 0 is just 1, right? Therefore gamma s gamma 1 minus s is integral from 0 to infinity us minus 1 upon 1 plus u. This is 0 plus 1 du, and you get gamma s gamma 1 minus s is integral from 0 to infinity u to the s minus 1 1 plus u du. Now let's turn back into our variable x, okay. Therefore gamma s gamma 1 minus s is integral from 0 to infinity x to the s minus 1 upon 1 plus x dx, which is same as this one now, right? Gamma s gamma 1 minus s is this integral. Now we are trying to prove that this integral is equal to this. Then it's easy, right? We know that gamma s gamma 1 minus s, this is Euler formula, Euler reflection formula, which is pi over sine pi s. Then substitute here. Then therefore integral from 0 to infinity x to the s minus 1 upon 1 plus x dx is pi over sine pi s, where this s is between 0 and 1, okay. Here the condition is that this s is between 0 and 1, okay. So this is the proof for this gamma integral.